Hi, what we're going to do today is we're going to explore something called an orthographic projection, which we're going to take this shape right here, which is a three-dimensional shape, and we are going to create some views of it on all of the sides. And these are going to be two-dimensional views of the sides. This is the solid that we're going to make our orthographic projections from. We're going to represent the front, the right side, the top, the left side, the back side, and the bottom of this solid. You can imagine an orthographic projection as being a bit like the shadow that would be cast by a solid. Not necessarily the size of the shadow, but the shape of the shadow and the amount of detail that you would see in that shadow. To start, we're going to divide our paper into 4 quadrants. We're going to measure up roughly 10 centimeters from the bottom of the page, and we're going to make some marks. And we're going to use this to draw our horizontal line. So a couple of marks up 10 centimeters from the bottom of the page, and then draw a horizontal line across. This makes sure, by doing these 2 marks, it really makes sure that you have a horizontal line and not a diagonal. We're going to now draw a perpendicular line that is at 90 degrees to the horizontal line that we just drew. So we'll start by making a mark in the middle of that line, and then using our protractor to draw a 90-degree angle. So we're going to put a point at the 90-degree mark at the top of the protractor. Just like that. We'll flip the protractor over, and we're going to put another point that is in the same line at 90 degrees. A point there, and then we're going to use our ruler to connect these 2 points together, and this is going to make our perpendicular line. Now we've divided our page into 4 quadrants. We're going to begin to draw our front view. So here's a reference for that. Remember, this is the 3-dimensional shape, so we're looking at the front there. We're going to start by putting a mark that is 1 centimeter on either side of the vertical line that we drew. We're then going to use our protractor, and we're going to make another mark at 90 degrees from the point that was 1 centimeter from our vertical line. And this is going to allow us to draw the left side of the front view. And this side is 4 centimeters long, so we're going to be using our ruler, and we're going to be measuring 4 centimeters. You'll notice that we're not actually using the 4 centimeter mark, but we are counting the number of centimeters. We're starting to draw the bottom here, and this is 6 centimeters long. Again, you don't have to worry about the fact that you're not at 0. You can use 0, but this is 6 centimeters long, so what I'm doing is just counting over 6 centimeters on my ruler. At the top, I'm going to make a horizontal line that is 2 centimeters long. On the right side, we're going to put the right-hand side of the shape, so we're going to make a vertical line, again, using our protractor to make sure that it is at 90 degrees. We're going to draw a vertical line that is 2 centimeters. We're now going to draw a horizontal line that is also 2 centimeters. And then we're going to connect the diagonal. There we go. Diagonals connected, and we see the front. We are now going to start making the right side. And this is really just going to be a rectangle because, again, if you imagine what it would look like if you were to cast a shadow on the right side, you would see simply a rectangle on the wall behind it. So we're going to start by drawing a nice straight line that is perpendicular to our horizontal line using our protractor. We're going to do that on both sides because this is a rectangle. And since this is a 4 centimeter tall object, we're going to measure up 4 centimeters. Again, I'm not starting at 0, I'm just going up from 6 to 2, which is 4 centimeters, and drawing the straight line. In this case, we're doing the same thing, 6 to 2. Then we can connect the top and the bottom. Now, we would see the line that goes across the center of our solid. This is where that diagonal line is. And so we're going to add that, and that is 2 centimeters tall. And we're going to add it straight across, and we're going to make this a solid line. The back of our solid will look very much like the front, except it's going to face in the opposite direction. So it's really a mirror image of the front. So the steps that we went through to do the front side are going to be exactly the same except facing the opposite direction. So once again, we're using a protractor. We're putting a point at 90 degrees on both sides of the right and left side of the back. We will connect them on the left-hand side here and on the right-hand side. On the right-hand side, it's going to be a 4 centimeter line. On the left-hand side, it's going to be a 2 centimeter line. We need to make a 2 centimeter line across the top. And then we're going to make another 2 centimeter line that's kind of on that step down. And then we can connect the diagonal. And that's the back of our figure. We'll just connect the bottom here. We are now going to draw the left-hand side of our solid. The only difference between the left-hand side and the right-hand side in this orthographic projection is going to be the middle line. In the right-hand side, we used a solid middle line, and that denotes that you would be able to see that edge. You would be able to see that edge where the diagonal comes up from the bottom step to the top step. Now, on the left-hand side, you would not be able to see that edge. It would be an invisible edge. So we would denote that using a dashed line rather than a solid line. But otherwise, the process of making the projection is exactly the same for the right-hand side and for the left-hand side. We're now going to draw the bottom of this solid body. So to start with, we need to do some measurements. So we're measuring down 1 centimeter along that vertical center line. And then we're going to measure 3 centimeters on each side of this vertical line. We want some vertical lines to come down from the ends of that horizontal line we just drew. We're going to use our protractor to make sure that they are nice and even and straight and perpendicular and at 90 degrees. Now there's a small error here. We should be drawing a 4 centimeter line, and you can see we correct that later, but you can see that we're drawing a 6 centimeter line just now. Now we accidentally drew a 6 centimeter line. We'll correct that later. We want to draw the left-hand side of this rectangle. Here we are correcting our error. So that was a 6 centimeter line. We're now putting a point at 4 centimeters. And then we're going to draw a line on the left-hand side of this rectangle that is 4 centimeters long. All of your measurements should match what the actual solid that you're trying to create would be. These are engineering drawings. That means that somebody should be able to follow these drawings and recreate the shape of the solid that you're trying to communicate. We need to put in the sort of step edges. So we're going to put one edge 2 centimeters in from the right-hand side and 2 centimeters in from the left-hand side. We'll make marks on the top and bottom of this rectangle in order to show that. And then we're going to connect those dots with some dashed lines. And that's going to show those invisible edges. Again, we're trying to say, hey, if you could see through this solid, you'd be able to see these edges. We're now going to draw the top of this solid. The only difference between the top and the bottom, as far as our orthographic projections go, is that on the top, we're going to be using a line rather than a dashed line to show the edges that are in the middle. So we're starting out with a 6 centimeter line. With our protractor, we'll draw our 90-degree angle. This side is 4 centimeters long. This side is also 4 centimeters long. And then we connect the top. We're going to measure over 2 centimeters from each edge, each side of our rectangle, to create those step patterns. We're going to connect this line, those points that we just made, with a vertical line. Again, a solid line rather than a dashed line. And that's the top. Now, you can go over this in pen, But remember, the whole point of this is that these are engineering drawings. That means that someone should be able to recreate our shape. And here's what a finished drawing using pen would look like. Thanks for watching.